So let's think of a simple problem. We've got an object which is falling down with 0 starting velocity. Here's the equation which represents its coordinate with respect to time. And the question is to find its instantaneous velocity in the moment of time 10 seconds. As far as we know now, velocity equals to distance over time. Now let's just write this equation using the definition of delta. In order to find the velocity at the moment of 10 seconds, we're going to shrink down the difference between current time and 10 seconds and calculate the corresponding velocity to each period of time. Now, looking at the values of the table, we may see that the resulting velocity is getting closer and closer to 10g, which is obviously going to be the right answer, because we're basically just decreasing time of the experiment, which makes it more precise. This way, according to the result of the experiment, we may rewrite our function as a limit of a function which we are calculating. So from now on, let's just switch the function of distance to the dependence of the function f from the argument x. And this way we may write our limit regarding the fact that x equals to x0 plus delta x. And this gets us to the limit where delta x approaches 0. And this simple transformation gets us straight to the definition of the derivative, as it is actually the limit of the ratio of the change of the function's value to the change of its argument, where the change of the argument approaches 0. We may also write this as df over dx, where d represents a small change, and the derivative itself is represented as a function with a dash on the top, and hence the process of calculating this limit is called differentiating. Let's give it a geometric interpretation. Here we can see that if the difference of both the function and the argument is small enough, the derivative of the function represents the slope of the tangent line to the graph of this function at a given point. So we can write it like this. The derivative equals to tangents alpha, where alpha is the angle between the tangent to this function at a given point and x-axis. Now let's try calculating a derivative of a couple of relatively easy functions. Let's start with just x squared. And just like that, following the definition of a derivative, we are able to calculate the derivative of x squared, which equals to 2x. Now let's try doing something trigonomic. Let's take sine x, for example. Here, in order to move further, we should know the formula of difference of sines. I'll write it down for you to know. Here we have to use a fact if the angle is relatively small, the sine of this angle is going to be close to the value of its angle. So let's just write the sine that we have here as delta x over 2. Just like that, keeping in mind that delta x approaches 0, we get that the derivative of the sine equals to the cosine x. And now I guess this is gonna be everything for today. If you wish to solve some additional problems, you may follow a link in the description of this video. And you are listening to Copper. Have a good one.